Alright guys, welcome back to my YouTube channel. Um, Today we're going to see about LoRa training. Now, LoRas are basically fine-tuning method for stable diffusion that allows you to fine-tune your model so that you can generate artistic styles of a particular kind. Or for example, if you have a specific concept that is not so easy to explain using words, you can use something like LoRa, which is a method of fine-tuning your model so that you can better specify and communicate, or basically teach your model to output images of that kind. Now, what makes LoRa cool is that, of course, you have all of these models that are derived from Stable Diffusion's base model, SD 1.5 or the later ones, but it's very hard to train these models themselves. For example, it requires much more hardware resources to train a full model, and therefore it's not so easy. But LoRa's are very easy to train, and they are much smaller in file size as well, which means you can do it, you can train a LoRa yourselves too without requiring very huge or expensive hardware. Also, it doesn't require, it makes sense that, for example, if your AI model, Stable Diffusion model, it doesn't need, a normal model has quite an extensive knowledge. It can generate a wide variety of things, of objects, of people, landscapes, but you do not need all of that resource to generate something very particular. And therefore it makes sense that, you can fine-tune your model on something very specific without requiring all the concepts that it already has. So to give you an example, say you need your AI model to generate a specific car. For example, something like a Benz or an Audi. It doesn't need to know about all the other concepts except its knowledge about cars in order to generate that particular kind of car. It doesn't need to know about people or anything else, basically. It just needs information about that particular kind of car, or maybe something related to cars. But it doesn't necessarily need all information about everything under the sun for it to generate a particular kind of a car. So that's exactly what LoRas are. LoRa stands for low rank adaptation, which as the name suggests, it's sort of making the model adapt to your training dataset. That's what a LoRa is. So basically I have here a diagram that enlists all the things a LoRa can be best used for. So a LoRa can be used to teach your model textures, which might be a bit vague about what I mean by texture, but if you think about images have certain textures attributed to them, and it depends upon the kind of objects that an image has, which could also be about the kind of style your image is basically having, for example, it could be photorealistic, it could be like a painting or an art that is medieval or something like that. So by texture I mean the kind of quality or the sort of aura, or a better word might be the kind of quality your image is going for. Also, it could be used for teaching your model certain concepts, certain patterns that that might not be very easy to prompt. For example, something like a ball that is on top of a table. Well, that is something very easy that you could probably already prompt. But let's think about something even more complex, such as a person holding, or a person sort of holding a briefcase or something like that. The idea is that it's a recurrent theme that you want your model to really have a solid foundation on. That also includes styles, which could be something like a certain clothing style, or a kind of facial expression, something like that. Also, it could be used for object relationships. For example, you have something like a certain architectural style that involves these repetitive elements, such as a particular kind of furniture, or a particular kind of something like a particular style of lamps, or window styles or door styles, anything that is recurring, repetitively present in your image, a recurring object that is present in your image, you can use a LoRa to train it. Now, one thing to keep in mind is that we should try to avoid using a LoRa to train something like perspective, or poses, or the actual composition of your image that you want to create. That kind of things are better suitable for control net. So a control net does not have extensive knowledge about the higher level concepts in your image. That is best left for LoRa. Whereas if you have a certain image positioning, or a certain pose, or the actual layout, that best is left for control net. Now, the reason why it becomes important is that you basically train a LoRa on a set of images. So keeping in mind these different things that a LoRa is best suitable for, helps you to choose what kind of images that you can train your LoRa on. So it's best not to train a LoRa on perspective or composition. Of course, there are many pose LoRas, but I think poses can be better exemplified using control net rather than a LoRa. Of course, that might be not 100% accurate, but your main focus when you generate a LoRa must be on these things rather than these, because these can be attained using control net after you have generated your LoRa, and they can be independently added when you generate your image. All right, with that out of the way, let's actually talk about training a LoRa. Now, this guide is inspired from this Reddit post over here, where the user, I don't know the username, whatever. I'll link this thread below, where the user goes about talking about how you can train your own LoRa using Google Colab for free. Now, unfortunately, you cannot run the stable diffusion web UI on Google Colab because they have actually basically restricted the usage of the automatic 1111 UI on Google Colab. You cannot run it on a free tier, but you can do training stuff on Colab for free even now, at least as of making this video. So hopefully they don't remove that feature soon. It could possibly happen, but let's keep our fingers crossed. So this is a very good thread, and I will link it below. And this is the images that basically have all the instructions on how to do that. So this is a basic. This is the main GitHub page, which is of the trainer that we are going to use. It's the Kohya trainer. So they basically have a local training script as well, which is basically based on Dreambooth's method, and you can use it on your local training, local setup, if that's possible for you. But it so happens that the online method using Colab is very straightforward, and it's, in my opinion, much easier than using the local one. And well, of course, the GPUs on Colab, even the free ones, are good. So with that said, let's talk about how you can prepare your own images, because basically you need a bunch of images as your training data set, which will be used to train your LoRa. So let's jump straight into that. So as you can see here, I'm going to train a LoRa on a couple of images that are about a particular architectural style. And I have a bunch of images here, to be exact, 39 of them. And talking about the kind of images that you want, you basically need high quality images, but that's not often attainable easily, because while you might not simply have them. All right, this image is repeating, so I'll just delete that. So we have 38 images right now. All right, you don't want to repeat any images. All right, okay, so that seems fine. Yeah, so about the quality of images. So typically it will be better if you have high quality images, but oftentimes you will not have that luck to find better images. The more obscure your stuff or whatever you're trying to train your LoRa on is, the harder good quality images usually are to get. All right, but let's not be depressed about the quality of the images. And talking about the image resolutions that you're going to need, again, it would be better if you have a uniform image resolution. Typically, it would be even better if you have the image resolution that your model works best on. But again, it is not mandatory. As you can see here, I have images of varying resolutions, and actually I have already trained a model on with the exact same dataset, and it usually works well. Now, to be honest, it works really well with if your training subject is about something like a fashion or a clothing style, or a person, for example, be it a particular kind of a fashion style or something, and it usually is not that good with with architectural styles in general, especially if your model has very little knowledge about the architectural style you're going for. So if your model in general produces not that great architectural styles, then which I think seems to be the case with a lot of models, then well, you should not increase your expectations too much. Anyway, as you can see here, we have a couple of images here, and I have it in this folder here. So basically what you want your training dataset to look like is that for each of your image, you need a kind of tag, which is a text file that has all the descriptions for that image. So basically for each image, you need to have a text file and their names must match. So if you have your text as a particular name, the image as a particular name, the text must also match that name, and that text file must contain description of what that image is going to be. So for example, let me just demonstrate how you can do that. So as you can see, when you download these images, they will come with all of these weird names. So I suggest you to number your files so that it's much easier. So this here, I will name it as the first file, and I will create a text document like, all right, so for some reason my Windows here is not creating that the file here, so I'll just create a text file. So as you can see, I've created a text file with the same name as the image I want to give the description of. And what you're going to do is basically, you should look at the image and open up your text file, and you want to give tags. So this could be, so based on experience, you shouldn't give out long descriptions as you would actually describe an image using long sentences and stuff. Keep it concise, keep it short, and don't use more than 2 or 3 words for a single token. So for example, I could give the tags for this image as the interior of a house, and then maybe something like courtyard, and then maybe focus about the lighting, which is a sort of a dim lighting. Now, the guide here, there's something interesting that this guide talks about, which you can read, as I'll be linking it below, is that you do not want to tag anything that you want to keep separate from your LoRa training. For example, what I mean by that is that if you are training a LoRa on a person and you're describing the tags of that person by, let's say, the kind of hair they have or the kind of clothes they are wearing, if you want your LoRa to automatically associate a particular dress or particular hairstyle for that subject, for that person you're training on, and not you want your LoRa to associate that particular hairstyle and clothing with that person, then you should not specify it inside inside your text file as tags. So I wonder if that makes sense, because that seems counterintuitive at first, because it feels like the more you describe the image, the more better the AI learns. But it happens that your images are making the AI, making the LoRa making the LoRa gain understanding with itself. So all these texts that you are separately giving sort of acts like additional information that helps the AI to extract information out of the image. So even if you do not have these tags, the AI will learn a lot. But the tags serve the function of sort of filtering out the things you don't want the AI to think the subject is. So for example, I am going in, if I want the LoRa here to, if I generally want dim lighting in the LoRa I train on, then I would remove this keyword, which means that after all these images the LoRa analyzes, if those images all have dim lighting in them, which is the case, all of these images generally have dim lighting, then, and if I omit it out of my tags, then the LoRa would automatically would have inside it the concept of dim lighting associated already. So you should basically keep tags that you want to filter out of your images, if that makes sense. So I will keep dim lighting here anyway, because I don't mind in the LoRa I train to generate brighter images as well. So be careful what you tag your images as, because that goes a long way in how your LoRa turns out to emerge. All right. Now, once you have done your basic tagging, image tagging, what you want to then focus on is to come up with a keyword. Now, a keyword is basically what would trigger your LoRa when you use it in your Stable Diffusion web UI. For example, when you use something like text to image or image to image, you have the option to enter text, basically, right? Well, you can choose to not have text in your image to image, but basically you have the option to enter text. So if you have enabled your LoRa, even if you have enabled your LoRa, if you choose to use a keyword in your training, your LoRa will only work when you have that keyword enabled in your text to image or image to image prompts. Now, personally, I would say it is better to have a keyword, so that when you share your images as well, it is better in the sense of organizing your images, so that you know that your image your generated images was actually using a LoRa. So even for that, I think it's better to have a keyword so that it acts as a trigger when you generate images. So the important thing about this keyword is that it should be present in all your text prompts. So you have all of these images. So you have to create a text file for the second image, third image, fourth, fifth, and so on. And all of those text files must have this keyword. So I'll just put keyword in quotes because you'll have to replace it with the actual keyword. So all of the text files that are tags should have this keyword at the beginning. And what that will do is that it will, during your training, the LoRa gets associated with that keyword, and it basically builds a very strong connection with that, which eventually results in your LoRa only getting initiated, only getting triggered when you use that word in your prompt. Now, what's important to keep in mind when you create your keyword is that it should be about something. It should be something that is that the model does not already have a preconception about. So something like something very obscure, so that the AI model, the base model, does not get influenced with that keyword. So something that includes some other characters, not just normal words. You could also include something numerical. All of these help in creating sort of this obscure word that only your LoRa gets attached to. Now you need this keyword in all your, so I'll just remove these quotes. You'll need this keyword in all your image descriptions, text files, so that it gets associated with this trigger, basically. All right, so that's basically how you would generate your tags. Now, it's very easy to do that if you're, to manually do it if your data set is just a couple of images. But if you have large number of images, it will take quite a lot of time to manually rename your files as 1, 2, 3, and so on. Also to create these text files. So in order to help you a bit, I have created this Python file, which is nothing complex. What it does is if you run it inside your image folder, training image folder, what it will do is it will check for supported image file types, because usually it's better to have it's better to have it in the popular image formats, so that you do not run into trouble when you're actually training the LoRa. The Google Colab does not turn out any churn out any weird errors. So it'll check for these popular formats, and then it will rename all of that into numbers, basically. And it will also generate these text files. So if it will generate as many text files with the same name as much as you have your images. So if you have 39 images, all right, there's 38 images in here, excluding the text file. It'll rename them first in numerical order, and it will also generate these text files for each of the image with the same name. And it will keep all of that in a folder named fwit. So what you can do is, I'll just what you can do is you can copy this Python file. I will have the link to this file in the description. What you can do is you can copy this file and go to your training dataset and paste it in here. Then go to your address bar and type in cmd. And what you want to do then is type in Python. So I assume you already have Python installed. And then type the name of the file that you just placed in there, which is prep.py. And as you can see, it has generated this folder with all of these images named in ascending order. These are the files having an associated text file. So I'll just place the tags of my first file that I have written here, and I'll just save it. So now you can go through each of the files, image files, and tag them according to the image that you have. So it's going to take some time, but also, as you can see, I have some weird file formats like WebP. So I would say it's better to have all of your training data sets in the same JPEG format, because you will basically eliminate any form of errors that you might run into. So you can convert that file into JPEG. Also, I have some other files as well that are in weird extensions. You can convert all of that into JPEG. You can basically do that with the built-in Photos app in Windows. Once you have done all of that and you have tagged your images, you're basically ready to train it on Google Colab. All right. So I have already tagged all of those images already beforehand. So as you can see, I have a different keyword here that I have placed in all the text files, so that the LoRa, upon being trained, sort of becomes attached to it. The next thing that you need to do is so as you can see, all of these files, including the image and its description, are in a folder, and that folder has this sort of weird name, right? And this name is important because it kind of specifies, when you train it, the number of steps the LoRa training will have. So you should name your folder in the following manner, which is steps underscore keyword. or it doesn't even need to be keyword. I just you can even give it your LoRa's name. So it should have the steps, which would be a number, and followed by underscore will be your LoRa's name. Now it's important to have this format because the Python code in the Colab notebook actually uses this naming convention to figure out how many steps your LoRa training will have, and this name will be what your output files are going to output safe tensor files. The LoRa training will output safe tensors, which will be the file format of your LoRa, and that name will be the name of those files will be the LoRa name you specify here. All right. So how do you figure out how many steps your LoRa should have? Now, so the steps are basically how many times your LoRa training iterates over each image, right? So if you have a total of 39 images, and each time for each image, your LoRa training goes over that image, say 5 times, then the total number of iterations that your LoRa training will have would be 39 times 5, which is like, let me just take the calculator here, which should be like 195. Now, you want your total number of steps to be something like 1,000 or something. Now, this is not a hard fixed number. You could choose something like 4,000 or something. It doesn't matter, but a good starting point would be something like 1,000. So the total number of iterations that your LoRa training will have, if it's 1,000 and you have 39 images, then the repetition that you want for each image would be 1,000 divided by 39. Now let's just round that as 40. All right, so let's just round that as 40. And you'll see that you'll need 25 steps for each image if you want a total of 1,000 iterations. So that's what we'll do. We'll put this as 25, and I will I will give the name of this LoRa as courtyard, because why not? All right, so once you have prepared your image dataset, let's head right into Colab and actually train it. We'll go to the notebook, Colab notebook, for our LoRa trainer, as specified in this tutorial, because it is the one that's consistent, and we do not have to change much settings at all. So basically, if you use the newer version of the Colab, it has settings that are very different, somewhat different, and you would need to mess them up differently, which you could write, but since there's already a guide for this particular Colab version that you can refer to if there are any errors or so, I suggest you use the same Colab notebook as specified here. So we'll just go to the Colab notebook they have specified. Let me just first thing that you can do is select the correct Google account that you want. Also, let me just open up my drive. All right, so once you have the Colab from the link, what you can do is you can save a copy in the drive so that you don't have to always get the Colab from the link. Now, they suggest one modification here in order to install Xformers, which is basically an optimization tool. And you'll have to go to install dependencies, click on this button to expand and show the code. And you basically have to change this line. We'll delete and then change it into this. So let me do that quickly. All right, so that looks right. And what you can do is save that, save your notebook to your account so that you do not have to make these changes again and load the notebook all the time through the link whenever you want to train a LoRa. So once this is done, basically you can save it and let's start running things on our notebook. So as before, we have already uploaded our training folder with the naming and the folder with the specific naming convention. So what I'll do is I'll just we have it in here. I'll just rename it as something like 15, because it turns out that 25 takes something like 40 minutes to train. So I'll just name it to 15 so that it's just 15 steps per image. All right. Once we have our dataset in our Google Drive, let's now start running things in our Colab notebook. First of all, we will install the Kohya trainer. We'll click this button over here to do that. And that's done. Next, we'll install the dependencies, which also has the thing that we have edited, Xformers. So I think this is going to take a while because there's some building here. So let's patiently wait. Took like a minute and 28 seconds. Now you could put your Hugging Face API token, which could be useful for downloading models or something, but we already have our models downloaded, so we are not going to do that. Then we are going to mount our drive so that we can save our files. Click allow, and it should mount your drive to your Colab notebook. Right, so as you can see, it's in here. So all your drive files can be accessed from your notebook. Next, we will straight away go to 5.1, where it says training model. We will give our project name as so, and here we will specify the model that we are going to use, which is Dreamshaper 7, and you can copy the path like so and paste it here. We are not going to use any VAE, which stands for variational autoencoders, which I think makes images and colors sometimes look better. But we are not going to do that to train or LoRa today, but you can always try that. Now here is the most important step, where you have to specify your training folder containing the images and the text, which we have here. Now what's important is we have our folder with our special name, steps underscore project name. What we actually need to specify here is the parent folder that contains that folder with the special name. So we are going to copy the path of that folder, and we're going to paste it here in the training folder directory. Now this regularization folder directory, rec folder directory, is basically going to have all your regularization images, but we are not going to use regularization in this LoRa training video, because I have trained some LoRas before, and in my opinion, when I have used no regularization images, it didn't affect much. But of course, maybe regularization images could even increase your quality much better, but I'm not sure about that. And it is often said that you need a large number of regularization images. Like for each training data image, you need something like 15 or 20 images. So that easily makes the total number of regularization images in the order of thousands. So if you have an easily available set of regularization images, so basically those would be images that are regularized, that are basically images of things that help your model separate, easily separate your training images. So for example, if you are training your LoRa about a particular brand of a car, like Benz, your training folder contains images about that particular brand, which is Benz, whereas your regularization images would be just plain cars or other automobiles in general. So we are just going to specify, we are not going to specify any regularization images, which means we will just keep it the same as your training folder images. And we will select output to drive, so that it will be saved in your drive. It will be saved in there will be a folder called output, and all your safe tensor outputs would be saved in there. All right, so once you have specified that, you should run this. All right, so next we will not change anything under 5.2. We'll just run it straight away. It has important things like learning rate and some important numbers that are very technical, and honestly I'm not exactly sure of what they do, but these numbers seems to work with the default values. All right, so finally we can actually train we can actually start training our LoRa using this column. So here we have to change a few things. We'll change the num epochs to 6. So epochs are like stages. So with each stage, your LoRa will become better, will become more adapted to your style or data set. So what we have to then change after setting num epochs to 6 is to change the save any epoch type to save every any epochs, which basically what we are trying to do is that we need a safe tensor file for each epoch. And basically what that does is that sometimes your model might get overtrained. By that I mean it might get too fixated on these concepts that it might deteriorate some of the features. So basically like diminishing returns, so to speak. So if you have a lot of stages, what you can do if your model, if your LoRa model gets overtrained, is that you could choose previous files. So the last file, which should be sort of numbered, would be the most trained one. And if you feel that like it's overtrained, you could choose a previous file. So we will choose the epochs as 6, and then we will keep this to save every n epochs, and then change this to 1, so that for every epoch it outputs a file. So also we'll choose clip skip as 1 and the C as random, so that we perform inference on the base model randomly. Once all of that is done, we can just click the run button in this column to actually train. So if everything works well, you should see it's starting to train. Now if everything goes well, you should not see any errors. It will take a little bit time to get things started. It will download maybe some more packages. So as you can see, it has already found our training images, which is good, and it has started to load the images. And if you check your resources tab here, you should slowly start to see the GPU RAM and the disk to slowly rise. Now we are training it using buckets, and once it starts to actually train, you'll see the number of steps it has completed and the percentage in terms of the process, how far it has gone. So this is going to be when it's going to take the longest. So let's just wait till it starts, and as you can see, it's downloading the PyTorch binary file, and once it gets completed, hopefully we actually start training. All the steps have been completed. So we have all the files, output files, saved in here. So well, there happens to be 10 files, presumably for each epoch. And we can see it in our drive here. And the last one here is the final version. So we could download this and check how good it is, which we are going to do. And if it turns out to be overtrained, we could either decrease the weight, which is a good way to correct if it were to be overtrained, or you could find any one of these files in between. Something like 7 or 6 could also work. Something like 1 would be not that capable. So you could use these something earlier, which could be the optimal version. So you'll have to try a couple of them to find out whether it's overtrained or not. But anyway, let's first download this one and see how well it performs. So we're going to do we'll do just that. So let me just download this file, and let's try this to find out how good it is. Alright, so I have stable diffusion open over here, and let's use our newly generated LoRa onto our text to image and see how good our trained LoRa is in generating the architecture we want. So as you can see, I have this is the model, the safe tensor file we had, and we'll have to place the downloaded file. So the file that you downloaded, you'll have to keep that in automatic 1111 stable diffusion web UI, and then under extensions you should have web UI additional networks installed. So this is an extension that allows you to run additional networks such as LoRas on top of text to image or image to image. So when you install additional networks extension, you will see that appear along with all your other extensions, and you can install it just like you'll install any other extension using the extensions tab and install from URL, or I'm not sure if it's available in the extensions index. If so, you can install it through there. Anyway, I will have the link for that extension in the description as well. So once you have installed that, you can enable it here and then choose the model as LoRa and the model as the one you have created. So if you paste the model in this path, extensions, SD, WebUI, additional networks and models, and then go to LoRa, and then if you paste under here and you restart your UI basically. So as you can see, I'm running it on my network, but it's not on the laptop that I'm currently using to record. So I already have a couple of other LoRas as well. So that's why even though I have only one here, it's showing many here because it's the Stable Diffusion web UI that I'm running now is actually on a different computer. So anyway, I have selected the LoRa model, and then I have hit enable so that it works when we click generate. And I have a prompt here. Now these prompts, I actually how I got them, while I actually ran a couple of generations, and with the image that I wanted to generate in mind, and then I tried my best to generate those images and found the flows that this model was having. So that actually became the sort of guidance for creating this prompt. So you should try to generate the image, the subject that your LoRa is about, without the LoRa initially, with just your bare models, the standard base model, and then find what features your model has that you want to keep and that you want to throw out. So that basically becomes your negative prompt, and the features that you want. Of course, it's not going to be good because, of course, the model might not have real knowledge about what that subject is. That's why you train the LoRa. But you try your best, and that becomes your positive and negative prompts. So anyway, this is the trigger word, and of course, initially when I used the model alone, it wasn't there. But now, since you are using it with your LoRa, you're going to have to add the trigger word as well. So with that done, and your additional networks extension enabled with your LoRa model added, you are good to go. So as it turned out, I found it best to keep the weight at 0.65. We'll see why. But let's just hit generate and see how the images are. So as you can see, it's already generating good images based on the architecture that we have trained it on. So it appears low quality, and that's true, but we can always upscale it and use something else like ControlNet to maybe straighten out the rough edges, make the architecture a bit more solid. But we are not going. We haven't used anything else right now. We are just using the LoRa and the model to generate these images. But we could potentially use something like ControlNet to further enhance and sort of make these edges and stuff more visible, and maybe even more straight, as it appears to be a little bit curved. So let's just hit the generate a couple of times more to see if we can generate better. As you can see, the AI is generating, let's just, how about we remove the additional network or LoRa and just see how much of a difference that really is, As you can see, this is a totally different image, and it's not even a courtyard, it's not even a house, it's some sort of a palace. Of course, the images seem to be much better in quality, but the architecture that we trained it on, we did not have high quality images. Those were basically ripped from the internet with whatever quality they came from. But the main point is that the model simply does not have any knowledge about the architecture that we trained it on, which is sort of a sort of traditional courtyard-like style. And as you can see, it's totally different when we it's totally different from when we had the LoRa enabled. Let's enable the LoRa and generate a couple more images to see how different the images are and how much of a difference the LoRa actually makes. So as you can see, the quality is a bit off, but I think now this is where the importance of high quality images comes into picture. The main point is that if your images are lower quality, then what happens is that when the LoRa is being trained, the LoRa kind of comes into the conclusion that even the image quality is something that should be emulated. So the LoRa kind of learns even the image quality. So if all that you have is a bunch of low quality images, then the LoRa basically learns the low quality as well. So that's something that you can only avoid if you have high res images, but it's all right because I don't think these images are that bad, that low of a quality that cannot be improved using something like an upscaler or even an image to image with less denoising or something. So I'm quite surprised with how much of a difference LoRa can make. And let's just hit the generate a couple of more times to see if we get some better courtyards. So as you can see, these are really good images. And if you look at the training images, it's kind of very similar to what the training images are, which are a bunch of courtyards, and it has really learned to emulate that style. And I'm kind of quite surprised by the floor. It almost kind of got it right with the reflection and the sort of texture that makes it appear wet and all. So it's really good. And the best thing is that you can add things on top of it, like you can do something like control net, where you can leave much of the texture like aspects to the LoRa itself, whereas you could kind of guide the architecture with the perspective and stuff to the control net, so that the control net can better take over the actual layout, actual perspective of the image, while the LoRa is more focused on the kind of style or the texture of the image. So that's something that you can do. Well, of course, it's something that you should keep in your mind when you train the LoRa, so that you can distribute the responsibilities like that from the beginning itself. But just out of the top, we are seeing tremendous improvement from when our model had no idea of what this sort of traditional architecture or traditional courtyard look like, to absolutely beautiful images like this with the lighting and the general style matching almost entirely with the dataset that we have. So I think this is the right time to end the video. If you have enjoyed this, consider liking, subscribing, disliking if you dislike. So if you want more videos, just show your interest in the comments. I might make a couple of them more. So that's it. Goodbye.